So this section is all about curve sketching by hand. So basically trying to come up with what a graph looks like with using calculus and without using a calculator. So we're in this section, we're going to be concerned really about looking at this graphing a polynomial function. Um, Other times, if we had more time, we'd probably do the graphing a rational function, but we're just going to keep it easy and do polynomial function. So that's the process we got to go through. And you don't have to do it necessarily in this order. Like the top, all this stuff up here kind of can be in any order that you want. Um, but yeah, so let's go ahead and just get to an example. So let's graph y equals x to the fourth minus 8x squared plus 8. So first thing is we might see if there's any x-intercepts. Well, this one, but that means we're solving this equal to 0. This doesn't really come out nicely. We could figure it out using quadratic formula and things like that, but it's not going to be super nice. So let's actually not worry about x-intercepts on this one. Um, we're just looking for a sketch. So if it's easy, if it factors or something like that, go ahead and do it. If it doesn't, well, we can probably get enough information without it. The y-intercept though, we should always be able to do that. That's y equals, and you plug in 0 for x. So I get y equals 8. So 0, 8 is my y-intercept. All right. Now we need to take the derivative. So y prime. We're going to find the critical numbers. Remember, the critical numbers are where we set the derivative equal to 0. So let's go ahead and do that. So set that equal to 0. To solve that, we're going to factor. So we get 4x, x squared minus 4. And then we can factor x squared minus 4 to be x plus 2, x minus 2. And so we get our critical numbers end up being 0 from the 4x term, negative 2 from the x plus 2, and 2 from the x minus 2 term. All right, now we need to do what's called making a sign chart. So I'm going to make a little chart here with my numbers. My critical numbers are across the top from smallest to largest. Those are my dividers. And I'm going to pick something smaller than negative 2, so let's say negative 3. Something between negative 2 and 0, say negative 1. Between 0 and 2, call it 1. And bigger than 2, let's call it 3. And now I need to figure out whether it's positive or negative. And I'd like to label my sign chart. This is going to be for f prime. Remember in last section, or in 4.3, we talked about how if the derivative is positive, then it's increasing. If it's negative, then it's decreasing. And also the first derivative test says if we switch from increasing to decreasing, we have a max. If we switch from decreasing to increasing, we have a min, a relative min. So let's go ahead and do that. So I don't really care about the values. I only care about the actual sign, positive or negative. So I like to use the factored form. You don't have to. You can just use a calculator and plug them in to the original if you wanted to. You could plug them into that guy. But I like to use the factored form because let me show you kind of the thought process I go through. Normally I don't write this out all out, but it's kind of nice to see it all written out. So if I let x equal negative 3, 4x will be negative. X plus 2 will be negative. Negative 3 minus 2, that'll be negative. So the whole result is going to be a negative times a negative times a negative, which is negative. If I let x equal negative 1, 4x is going to be negative. X plus 2, so negative 1 plus 2 is 1, so that's positive. Negative 1 minus 2 is negative 3, so that's negative. If I have a negative times a positive times a negative, well, that's positive. Now if I let x equal 1, 4x, well, 4 times 1 is 4, so that's positive. 1 plus 2 is positive. 1 minus 2 is negative. Positive times a negative is negative. And finally, x equals 3. 4 times 3 is 12, so positive. 3 plus 2 is 5, so positive. 3 minus 2 is 1, so positive. And a positive times a positive times a positive is a positive. So this is how I have my sign chart. And what this tells me, remember, first derivative test, decreasing to increasing tells me this guy, that negative 2 is going to be a local minimum. Also at 2 is going to be a local minimum. Then from increasing to decreasing is a local max. So now we need to figure out what those are. So let's go ahead and figure out what those are. How we're going to do that is we're going to plug them into the original equation, right? That's how we always find y values. So we're trying to find the y values. Let's plug them back into the original equation. So f of negative 2, and again, we're plugging in these guys down here, right? We're plugging in those critical numbers, not the -3, -1, not those ones. Those were, we already plugged them in to determine whether the derivative was positive or negative. Now we want to know the value of the y value, so we're just going to, at the critical numbers, so we're just going to plug those directly in. So I get -2 to the fourth minus 8 times -2 squared plus 8. So 2 to the fourth is 16, and then I get -32 is -16 plus 8 gets me -8. So I have a, let's go ahead and write it down here. We have a local, what was that, minimum at -2, -8. Let's plug in 0. Well, that's nice and easy. We already actually kind of did that. 0, 8. Right? 0 to the fourth minus 0 squared plus 8 gets me 8. Then f of 2 will going to actually give me the exact same value as what I got up above, so I get -8. So I have my local minimums are at -2, -8, and 2, -8. And then I have a local max at 0, 8. So if we're gonna, let's plot some of these on here. We know, let's just have these go by 2s. So 2, 4, 6, 8. So, and then, so let's have these go by 1s. 2, 4, 6, 8. And so I've got those points there. All right. Now, I kind of know already it's going to look something like this. And then this is, all right, those are mins and maxes, so I kind of know the general shape of what they're going to look like. Now, you could connect them and get a pretty good idea of what the graph looks like, but let's go one step further. So now let's go ahead and I'm going to erase this work because I need a little bit of space here. So now we're going to take the second derivative, and we're going to talk about the concavity that we learned about in 4.3. So we take the derivative again. So I get y double prime is equal to 12x squared minus 16. And remember, our possible inflection points are the zeros of this. So I'm going to do exactly the same process I did over here for y prime, except for y double prime. So notice we can factor 4 out of both of these. 3x squared minus 4. And we're going to set that equal to 0. So that's 3x squared minus 4 equals 0. 3x squared equals 4. X squared equals 4 over 3. So x equals plus or minus 2 over root 3. So let's just go ahead and let's just see what that is here. 2 over square root of 3. So that's about 1.15. Okay, so those are our inflection points. So now I'm also going to, let's just call that x. I'm going to plug those into the original. And so x to the fourth minus 8x squared plus 8. And so that's -8/9. So at 1.15, -8/9. So basically we're kind of looking at this point right here and this point right here, because it's symmetrical, are going to be my inflection points. So that's going to be where the concavity switches. So now I can draw my graph. I know I'm decreasing everywhere to the left of -2. So basically, as I go to the left here, I'm decreasing left to right. Then I have a minimum there, and I'm concave up. And then when I hit that point, that's when I start curving. The curve switches kind of. So it's hard to see on this, but to exaggerate, it's where it goes from bending upwards to bending sideways. And so I'll label the points in just a second here. But let's try one more time. Something like that. And then goes on like that. So, and that's always concave up. So there's our sketch of our graph. Now let's pull this up on Desmos here, see how we did. So there's our graph on Desmos, and looks like we did a pretty good job. So really, again, it's just following this process that I laid out at the start of the note. So if you just follow these ideas here, you'll get everything you need. So I might be asking you for the inflection point, so let's go ahead and make sure we label this. This was -2 over root 3, -8/9. This was 2 over root 3, 8/9. This was 2, -8. This was -2, -8. And that was 0.8, so that's good to go. And that's everything we need. So